Hello everyone. Today I wanted to talk about electrical generation. Something the book did not talk about yet is the difference between primary and secondary energy. So when we talk about electricity, we're talking about secondary energy. It's a type of energy that's been converted from one form to another. So that means that we have to have some kind of primary energy source to be able to quote unquote fuel electrical generation. And you read lots about electrical generation in your chapter today, but I did want to highlight a few things that the book did not cover. So from this figure here, we can see, this is your figure 913 in the book, we can see in the United States our electrical generation kind of is very varied in the type of primary fuel that we use to get that electricity. So you can see that by far in the United States today, or at least in 2013, coal was the number one way of producing electricity in the United States. And that's just because basically we have so much of it compared to other places in the world and compared to the other resources that we could use as primary sources. We also use a lot of natural gas for electrical generation. It's a fairly clean fuel as far as fossil fuels go, and we still have some of it, so we are using it. Of course, very little crude oil is used for electrical generation. We use that mostly for transportation in our cars. We have a significant nuclear input into our electrical grid here in the United States, 19%. And then the screen represents biomass, which would be like burning wood or dung, animal dung, something like that, which is done much more in different parts of the world than it is here to generate electricity. And then this would be the category that we're most interested in moving into the future, which is other renewables. So this would be wind and solar and other types of renewable energy, whereas the other primary sources are really made from non-renewable primary energy sources. These are things that we cannot replace in the same amount of time that we're using it, whereas renewables like solar and wind, we obviously don't run out of those things. So this is the energy input to generate electrical energy in the United States. And the thing I wanted to point out here was a lot of times we focus on electrical energy as a clean energy. But in reality, we really have to stop and ask ourselves, what is the primary energy source for that electricity? Because that makes a very big difference as to how clean that energy is. So when you go out and purchase an electrical car and you're doing that for the environment, that's wonderful. But you have to ask yourself, where is that electrical energy coming from? It's a secondary energy source. What is the primary energy source? And the obvious answer here is in the United States, most of our electrical energy is generated between coal and natural gas, both of which are fossil fuels. So it's as if you're powering your car with crude oil, basically, in many cases, because even worse with coal, because it's even more of a polluter than the electrical energy that combusts crude oil would be. So how clean is electrical energy? Yes, at the source it's clean. You don't plug in your hairdryer and get a puff of nasty coal smoke. But there is nasty coal smoke associated with that generation of electricity if you live in the United States for the most part. Another thing I wanted to look at was you can compare the United States' breakdown of secondary energy primary inputs for electricity to Brazil, and you can see that there's a huge difference depending on what country you go to. And as you can see, Brazil has very much limited the amount of electrical generation from primary sources that are non-renewable, and instead has focused on those renewable resources. So it's not impossible, it just requires a country that has this as an important agenda for them to be able to generate large amounts of electricity from renewable types of sources. And of course, be able to get those renewable sources in a reasonable way. Another thing I wanted to point out was this figure. This is really old. It's from an old book that I used to use, but I really like this figure because it talks about energy efficiency. If you go back to some of the earlier chapters that we did, I even did a lecture on the laws of thermodynamics and how energy cannot be created or destroyed. And when you convert energy from one form to another, you always lose energy in the process because energy is lost as heat to the universe. So if you don't remember that, you can go back and listen to that lecture in one of the first lectures that I did. But this principle is applied here in this figure. It's very complicated looking, but it's not that bad. So over here we have the primary energy source. These are oil and refined types of products from oil. Here we have natural gas, here we have coal, nuclear power, and then wood and other types of sources of primary energy are kind of clumped into this light blue area here. And what you can see is, number one, maybe not so important for our chapter this week, is what are we using that type of primary fuel for the most part. So here, of course, we're using oil primarily just for transportation. What we're focusing on today is electricity. So if we look at electrical power generation in the United States, and this is fairly similar to what it was back in 1997 when this figure was made, you can see that still by far most of our electrical power is being powered by primary energy of coal, which is the figure I just showed you. Of course, we have nuclear contributing, wood and other renewables and things like that, but coal is really still the primary input into our electrical power generation. Now, what's really cool is to look at when electrical power is generated. In other words, we take a primary source, it doesn't matter what kind of source, and we generate electricity. We're converting from one form of energy, the primary energy, into another form of energy, the secondary electrical power. And when we do that, we are going to lose energy in the process. And so here, I like this last bar because it shows in the purple the work achieved from that energy conversion compared to the work that's wasted, which is this gray area in that energy transformation. So you can see that oil transformation in the combustible engine of a standard car is actually very, very inefficient. The amount of energy we're getting out in the ability to move that car compared to the amount of energy that we're wasting is very, very significant. Electrical power generation, we get about 33% of the power out, the usable power out of the electrical conversion from a primary to a secondary energy in the form of electricity. So really we're wasting, 66-70% of the energy that we could be getting from that coal is being wasted to the universe's heat. So this is just another demonstration of how much that second law of thermodynamics comes into play. We really have little work achieved compared to the amount of work that's wasted when we convert to electrical power. So just wanted to make the point that electrical power can be clean, definitely is clean in many cases, but it just depends on the primary source. So always ask yourself, where is this primary energy coming from? Where is my electrical power generator getting its primary energy? And here in the US, unfortunately, that's still coming from a very dirty, the dirtiest type of primary energy that we have environmentally, which is coal.